Alrighty, hello everybody. Today we're going to talk about multi-step equations, right? So we're going to be able to solve these types of equations that have variables on both sides, right? That's one of the big differences from what we've been doing in the past so far. So we got this whole long list of steps. So if you need to pause for a little bit and write these down, that's okay. Feel free to do that. All right, let's talk them through. So our very first step that we want to think about doing for these equations we're going to practice is distributing to clear any parentheses. Right, so if I have any parentheses, I want to go ahead and distribute what's on the outside of them so that way I can get rid of them, right? And just remember that distributing is like fancy multiplying. After that, we're going to combine any like terms that we have, right? And what we're going to do is we're only going to combine them if they're on the same side of the equal sign, right? Some might sound a little bit strange. You'll see more of what I'm talking about when we get into some problems, right? And when we're combining like terms, it's usually adding or subtracting to do those. Right. After that, we're either going to add or subtract all the variables to be on one side of the equal sign, right? And I guess we could add that on one side of the equal sign. After that, we have all our variables on one side, right? Then we want to add and subtract all of our constants, right? All our numbers by themselves to the other side, away from where the variables are, right? So we want our variables to all be on one side, right, like 3x, and all our constants to be on the other side, like 12, right? So that's kind of what we're going for, is on opposite sides of the equal sign. After that, we either need to multiply or divide in order to clear the coefficient that's on the variable, right? So in this problem that I just kind of sketched out, right, 3x equals 12, let's kind of zoom in. Remember that 3x is really 3 times x, right? So that's another way to write the exact same problem. When I've got 3 times x, the way that we undo that 3 times is to divide by 3 on both sides, right? So then we'd clear the coefficient, right? Zoop, they'd be gone. X is equal to 12 divided by 3, which is 4, right? So these are steps that we want to be thinking through, right? Sometimes we won't need to do every step, right? Sometimes we might not have any parentheses to distribute, and we might not have any like terms to combine, and then we only got to worry about these last 3 steps there. Right? So don't be freaked out and be like, oh, every problem is going to take 4 hours, right? We don't need to do every step every time. Let's jump right in. We're going to solve this first equation. So again, first thing I'm thinking of is, do I need to distribute? And the answer here is no. I don't have any parentheses to worry about, so that's nice. After that, do I have any like terms to combine? Right? And this is where it gets a little bit tricky right off the bat. You might be thinking like, oh yeah, 8x and 5x, those are like terms with each other. Let's smush them together. But unfortunately, they're on opposite sides of the equal sign, right? So that's not something that we want to do. So something that I've seen people do, and if it works for you, feel free to do this, is that they like to take the equal sign and just kind of like put a little line all the way down to kind of keep the sides distinct from each other, right? So if you want to do that, I'm going to do it on here, see how it goes, right? So, we've already talked about we don't need to distribute. We don't have any like terms to combine on the same side. So now we're already moving on to moving our variables around. So what I'm going to do is I'm going to try and move these 5x's over to the other side, right? And the way I'm going to do that is pretty similar to what we've done in the past. If I have 5x over on the right-hand side, the way that I get rid of that is to subtract 5x, right? And because we have an equal sign, right, what I need to do is the same thing on the other side, right? When I'm doing it to the other side, right, notice that I'm subtracting them from the 8x, right? So I'm kind of like grouping them because those are like terms. I can't subtract 5x from 4, but I sure can subtract 5x from 8x, right? So when I do that, 8x minus 5x leaves us with 3x. That plus 4 is still there, equal sign in the middle. And then over on the other side, those 5x's are gone, right? We canceled that out, and now we're left with is minus 14 or negative 14. Okay? So we've now moved our variables over to one side. They're all the way over on the left. Now what I need to do is I need to move any constants that are hanging out over to the right? Get them away from where the variables are. So what I'm noticing is that I have this plus 4 over here that's hanging out next to 3x, and I don't want it there anymore. So because it's plus 4, instead what I'm going to do is I'm going to subtract 4 to move that on over. All right. So when I do that, right, I still have 3x. Those 4's are gone, equal sign in the middle. And then negative 14, take 4 more away, right? So again, remember, if we're in the negatives and then I'm subtracting further, I'm going to end up further negative. I'm going to end up with is negative 18 there, right? So 3x equals negative 18. Last step, right? We have 3x, right? And remember just what I was talking about a little bit ago? 3x is really 3 times x. So what we need to do to undo that is to divide by 3 on both sides. All right, so on the left side, right, those 3's are going to cancel each other out. We're going to get just x. We got an equal sign, and then negative 18 divided by 3 is negative 6, right? Cool. Once we get to that, x is by itself. We know what it's equal to. That's it. We're done, right? So, hopefully this doesn't seem so bad, right? We just moved our variables over. We moved our constants away to the other side, and then we divided to get rid of the coefficient, and that was it. All right, what I'd like you to do is take a crack at number 2. Right, so pause here, try that one out. Hopefully you did that, right? So first thing I'm going to do here, right, is, and if this helps, I'm going to put out this little bar to kind of keep the sides separate. I'm going to think through my steps, right, up at the top of the page. I don't need to distribute because I don't have any parentheses. All right, cool. I don't have any like terms that are on the same side, so I don't need to combine any like terms. Cool, all right. After that, what I need to do is I need to start moving all of my variables to the same side. All right, so let's say that I wanted to move these negative 6x's over to the right. All right, and if you move those negative 8x's over to the left, right, if you tried this one on your own, that doesn't mean that you were wrong, right? There's multiple ways to tackle these types of problems. But again, what I'm going to do is I'm going to take those negative 6x's, and the way I'm going to cancel them from the left is I'm going to add 6x. I'm going to do the same thing over on the other side to keep everything nice and even. All right, so those 6x's are gone. All I'm left with over there is negative 1. Over on the right-hand side, I had negative 8x's, and then I added 6. So I'm going to bring it up to negative 2x. All right, and then that minus 5 is still there. All right, so after that, all of my variables are now over on the right-hand side. What I need to do from here is I need to move all of my constants, right, the numbers by themselves, over to the left-hand side. So that means that minus 5 is going to have 5 added to it, so we can move that on over. All right, so negative 1 plus 5 is 4. Over here we got negative 2x, and then those 5's are gone, right? We canceled them out. That was what we were hoping for. All right. Last but not least, negative 2 times x over on the right-hand side there. We'll divide by negative 2, and that'll help us get rid of it. All right, so 4 divided by negative 2 is negative 2. Over on the other side, those negative 2's are gone, and we just have x. All right, so this is where we're at. Negative 2 is equal to x. If you did it out like the other way, right, if you started by adding 8x to both sides, then your answer will look probably like this, x equals negative 2, right? Those mean the same thing, right? No worries either way, right? So sometimes when I'm working through a problem, I might be doing it a little bit differently than somebody else, and that's okay. That doesn't mean that one of us is necessarily wrong, right? Obviously, we still want to solve it correctly, right? But taking the steps a little bit differently might not mean that it's incorrect. Okay, let's flip over onto the next part here, right? Let's try this one out. So on a problem like this, what I'm noticing is right off the bat, I have some parentheses. So as I'm starting this one out, I know I need to distribute. What I'm going to do is I'm going to take this 7 and I'm going to distribute it to each and every part of those parentheses. All right, so let's do that. So 7 times negative 4x, right? 7 times negative 4 is negative 28, and then that x tags along. 7 times 6 is 42. Over on the other side, nothing happening. I'm just going to bring all that right on down. All right, cool. So distribution's done. I don't have any like terms on the same side to combine, right? I forgot to do my little thing to break up the sides. All right, so what I now move on to is moving my variables around. All right, so how about this? Let's add 28x to both sides so we can move that away from the left-hand side. All right, so when we do that, those 28x's are gone. That 42 sticks around. Over on the other side, negative 6 plus 28 is going to bring me up to 22x, and then that minus 2 hangs on. Okay, after that, what I need to do is I need to add 2 to both sides, all right, because I need to move this 2 away from where the variables are. When I do that, I get 44 over here. I get 22x, and those 2's are gone. Our very last step is to get that 22 away from the x, right? So again, 22 times x is really what's going on there. To undo that, I need to divide by 22. All right, when I divide 44 by 22, I get 2. Over on the other side, the 22's cancel, and I'm left with just an x. All right, so 2 is equal to x, or x is equal to 2. They mean the same thing, but it does mean that we're done. All right, so hopefully it doesn't seem so bad. All right, this one's pretty similar to that last one, right? So again, pause here, give this one a shot, see how it goes. Again, worst thing that can happen is that you're wrong, and who's going to even know, right? So hopefully you tried that one out. All right, same kind of deal to start. I'm going to take this 2, and I'm going to distribute it into those parentheses. All right, so 2 times 2x is going to give me 4x. 2 times 1 is 2. All right, same thing as the last problem. There's nothing happening over on the right-hand side. Okay, so I'm going to move my variables around. This time, let's move this negative 3x over to the left. All right. And when I'm choosing which one to move, right, the way that I like to do it is I like to move the smaller amount, right? So negative 3 is less than 4. On this last problem, when we moved the 28x over to the other side, negative 28 is less than negative 6, right? If you don't really want to work with that way, if you just want to move like, oh, let's always move them to the left, it'll still work out just fine, right? So I'm going to move this 3x over, and I'm going to do that by adding it to both sides, right? Because what's going to happen is 4x plus 3x will give us 7x. That plus 2 is still there. And then over on the right-hand side, we canceled out the 3x, which is what we were hoping for. We're left with negative 40. Right? Something to mention is don't forget about things like that minus sign, right? When you carry that down, that is still a negative 40 there. Right? After that, all my variables are on the left. I need to move all my constants over to the right, so I'm going to subtract 2 from both sides in order to do that. I'm left with 7x. The 2's are gone. And then I get negative 42 over there. All right. So after that, 7 is 7 times x. So we're going to divide by 7 on both sides. And x is equal to negative 6. All right. So hopefully that one went all right. Right? When I'm saying and suggesting, like, hey, pause here and try this one out, I'm really mean that, right? The only way to get better at math is to practice it more, right? Or else it doesn't really help, All right, let's try number 5 out together. All right, so number 5, looking kind of similar to the last couple, right? There's some distribution to do, right? And then spoiler alert, we might have some like terms to combine on this one. So what we're going to start off with is just the distribution, right? That's our very first step. I'm going to take this 5, I'm going to distribute it into the parentheses. Right, just like I've mentioned in class, don't go and make the mistake of saying, oh, and then I also got to distribute it to that minus 6. That minus 6 isn't in the parentheses, so we leave it alone. All right, so over here on the left-hand side, 5 times negative 3x is negative 15, and the x hangs on. 5 times 8 is 40. Still got that minus 6. We got an equal sign, and then the right-hand side stays the same. Right, I haven't changed anything over there. So after that, right, this is our very first one where we're going to have some like terms to combine. So what I'm noticing is over on the left-hand side, we have a positive 40 and a negative 6. Those sure seem like things that we could smush together. Right, so when I'm going to do that, right, I'm going to get negative 15x is still going to stay the same. And then 40 minus 6 is going to bring me down to positive 34. All right, so again, that step is literally just smushing those two pieces together. Okay, so after that, now we can go ahead and we can start moving things across the equal sign, right? So just like I mentioned on the last one, right, I like to move over the smaller number for the variables, Negative 15x is less than negative 6x. All right, so I'm going to add 15x to both sides to get rid of that. I'm going to add it over there as well. All right, so those 15x's are gone. We got a 34 left over there. Over on the right-hand side, negative 6 plus 15 is going to bring us up to positive 9 with an x on it. And then that minus 20 stays the same. Okay. All my variables are on the right, which means I got to move that negative 20 over to the left. The way I'm going to do that is by adding it. All right, 34 plus 20 is going to give me 54. We're going to have 9x, and the 20s are gone. Last but not least, we got to get rid of that 9, so we'll divide by 9 on both sides. 54 divided by 9 is just 6. On the other side, we get x. All right. So I know that these problems aren't like super quick and super easy or anything like that. I know that they might not be the most fun, but honestly, these are the types of equations, that you might actually run into in like future science classes, future math classes, right? It's going to be important to be able to solve things that look like this. Okay. So, as always, right, what I would really suggest is pause here, try this one out, then unpause when you think you got it. Okay. So on this one, we got 8x plus 9, looks fine over on the right-hand side, or on the left-hand side there. But then over on the right-hand side, we've got this 6 that I'm going to distribute into these parentheses. All right, and again, don't make the mistake of distributing it to that 3x. That 3x, or that plus 3x on the very end over here, is not in the parentheses, so that's not included when we distribute. All right, so 8x plus 9, hunky-dory, equal sign. 6 times 3 is 18 with an x attached. 6 times negative 5 is negative 30. And then we got that plus 3x hanging on the very end. Okay, so from here, what we need to do is we need to, combine some like terms. What I'm noticing is over on the right-hand side, I have 18x and then also a plus 3x that I can combine. So let's go ahead and do that. All right, so we've got 8x plus 9, still keeping the same, the 3 lines down. When I'm combining those x's, right, I had 18 of them, and then I'm adding 3 more. So altogether, that's 21 x's. And that minus 30 sticks around as well. Okay. So now we need to move our variables around. 8 is less than 21, so I'm going to move this 8x over to the right-hand side. All right, so to do that, I need to subtract 8x from both sides. All right, so those are gone. We're left with just a 9 over there. 21 minus 8 on the right is going to leave us with 13 x's, and then minus 30. All right, still making our way along. All my variables are over on the right-hand side, which means I need to move all my constants to the left, which means that negative 30 has got to go. So if I add 30 to both sides, that'll get me where I want to be. We're going to get 39 equals 13x, and the 30s are gone. Right. Last but not least, we got to get rid of that 13, right? So just like with other ones, to get rid of that coefficient, I'm going to divide by what it is. I'm going to divide by 13 on both sides. 39 divided by 13 is 3. 13s are going to cancel out over on the right-hand side, and we're left with just x. 3 is equal to x, and that's it. That's all we got. All right. So we are almost there. All right. On some of these, we might end up having 2 different bits of distribution to do, right? So something like this one, I'm going to be distributing that negative 3 to the stuff in that set of parentheses. I'm going to be distributing the 6 to that set, right? So, it's real important to make sure that you only distribute to the parentheses you're next to, okay? So when I do that over on the left, negative 3 times x is just negative 3x. Negative 3 times positive 4 is negative 12. Okay. Over on the right-hand side, 6 times x is 6x. 6 times negative 5 is negative 30. Okay, cool. So now it just looks like one of the problems we started things off with, right? I need to move all my variables over to one side. And again, it doesn't really matter which side you choose to move, right? It should all come out the same. What I'm going to do is let's subtract 6x from both sides. Let's move that over to the left. Why not? When I do that, over on the left-hand side, we have negative 3x minus another 6x. It's going to bring me down to negative 9x's. That minus 12 sticks around. Over on the right-hand side, those 6x's are gone, but we still have that minus 30 kicking around. All right, after that, all my variables are on the left-hand side, which means that the negative 12 has got to go over to the right-hand side. Right? We don't want any constants hanging out with the variables anymore. So we've still got negative 9x. Those 12s are gone. And then negative 30 plus 12, right? This is one where it's pretty easy to make a mistake on. Actually, I'm having a little bit of a brain fart moment. It should come out to negative 18, but just to be absolutely certain, never hurts to use a calculator. Negative 18 it is. Alrighty. All right, so you just saw me do it, right? Sometimes your brain just doesn't work, especially early in the morning like I'm doing this now. Right? It's never a bad thing to use a calculator. Use it if you need it. All right, so from here on out, negative 9x equals negative 18. That negative 9 in front of the x has got to go, right? But we don't want to add it, right? Because it's not negative 9 plus x. It's negative 9 times x. So we need to undo it by dividing. When I divide by negative 9 on both sides, they cancel out over on the left. We are left with just an x. And over on the right-hand side, it just comes out to be positive 2. Right? That's all we got to get. And then we're done. Right? So this is pretty similar to the last one. Right? Again, pause here, try it out. At least the first step, see if you got distribution down pat, and then unpause when you want some help. So hopefully you did that. Right, I'm going to start off the same way. I'm going to go ahead and I'm going to distribute that negative 3 into that first set of parentheses, this negative 5 into this set of parentheses. All right, so over on the left-hand side, negative 3 times 3x is negative 9x. Negative 3 times positive 1 is negative 3. All right, over on the right-hand side, we have negative 5 times 2x is going to give us negative 10 with an x on there. And then negative 5 times negative 1 is going to end us up with positive 5. Right? So it's real important when you're distributing a negative to pay close attention to negative signs that are in the parentheses. Right? So now it's just moving my variables around. I'm going to add 10x to both sides to move that over to the left. All right, so when we do that, negative 9 plus 10 brings us up to positive 1x with that minus 3 around. Over on the right-hand side, those 10x's are gone, and we're left with just a 5. So after that, all my variables are over on the left-hand side, which means that negative 3 has got to move over to the right. And so we add 3 to both sides, we're left with just 1x. The 3's are gone, and then we get 8 on the other side. So I'm going to tell you is that 1x is actually the exact same thing as just regular old x, right? We don't really need to do anything. You could think about it as like, oh, let's divide both sides by 1. But dividing by 1 doesn't actually really do anything for us, so we could just drop the 1, x is equal to 8. Okay. So we've done some problems where we didn't need to distribute. We've done some where we needed to distribute once. Some where we needed to distribute and then combine some like terms. We've done some problems where we needed to distribute twice. Let's throw it all together into one problem. We're going to distribute twice, and we're going to have to combine some like terms. Right? So again, I know that these are not going to be the most fun thing you're probably doing today, right? But let's kind of talk them through together. So negative 8 is going to distribute into that first set of parentheses. Over on the other side, I have this negative 7, right? I want to grab that sign that comes in front of it. I'm going to distribute that to that set of parentheses. All right, so if you're wondering about that little 2 hanging out in the middle, nothing happens with it right now. In fact, I could probably just write it down over there right now. That 2 is going to stick around. All right, let's focus on the distribution that's in red. Negative 8 times negative x is going to give me positive 8x. Negative 8 times positive 4 is negative 32. Okay. Over on the right-hand side, we have negative 7 times x is negative 7x. Negative 7 times negative 8 is positive 56. Okay. So, distribution done. What we got to do after that is we do have some like terms to combine. So over on the right-hand side, I'm noticing that I have this 2, and I have this 56. Well, I sure as heck can add those together, right? They're just numbers. So over on the left-hand side, nothing changes. 8x minus 32. Over on the right-hand side, 2 plus 56 is going to give us 58. And then that minus 7x is still around. Okay. So after that, we got to move all our variables over to one side. All right, so how about this? Let's add 7x to both sides to move them over to the left. Because why not? All right, 8x plus 7x is 15x, with that minus 32 still there. We've got 58 over on the right, and those 7x's are gone. And so all my variables are on the left. That negative 32 has got to move over to the right. So I'm going to do that by adding it. We'll get 15x, the 32's are gone, and then over on the right-hand side, 58 plus 32 is going to give us 90. All right. Last but not least, 15x is 15 times x, so let's divide by 15 on both sides. All right. When I do that, the 15s are going to cancel on the left there. We're left with just an x. And then over on the right-hand side, 90 divided by 15 is going to leave us with 6. Okay. So I know that we just kind of rocketed through that problem, trying to make sure that you guys don't have to listen to me for like 45 minutes. But what I'm hoping is that each and every step of this didn't seem so bad overall, right? Let's kind of break it down real quick. All right, so we started off with distribution. Oops, somehow I switched over to the laser pointer thing. That looked cool. So distribution is what we did first. After that, we combined like terms. All right. So distribution, combining like terms are things that we've practiced already, right? If you're feeling a little bit shaky on them, this is more practice to help you get a little bit better. If you still want some more help, that's what I'm here for. All right. So after we distributed and combined like terms, then we were here. Right? And what we did was we moved around our variables. We either added or subtracted variables to one side. Right? What I'm writing down right now, you don't need to write down on your paper, right? Sorry, I should have mentioned that at the start. But, I'm just kind of breaking it down. Like, these are the steps that we were taking. This is what they look like in a problem. So after we moved all our variables to one side, we were down here. When I take my next step, what I'm doing is I'm adding or subtracting the constants to the other side. All right, and it really is important that they go to the other side, away from where the variables are. And last but not least, in this case we divided, but overall we would multiply or divide to clear the coefficient. Right? And clearing the coefficient is what allows us to get just x by itself, right? No numbers hanging out in front or anything, right? So, all in all, it's 5 steps, and they're not like 5 super easy steps or anything like that. Sometimes they can be pretty difficult, right? But take it one step at a time. Don't look at a problem like this and be like, oh my God, I got to do this and that and this other thing. Just do one thing at a time, then move on to the next thing. Right, it's going to make it seem a lot more manageable. All right. So, again, what I'm going to recommend is pausing here, trying this one out, see how it goes, right, and then unpause when you think you got it. All right, so same kind of deal as the last one. Over on the left here, I'm going to distribute this negative 3 into those parentheses. Over on the right-hand side, I'm going to distribute that positive 3 into those parentheses. Excuse me. All right, so that 6x hanging on to the very end is not in parentheses. We leave it out when we're distributing. Okay, so over on the left, negative 3 times x is negative 3x. Who would have thunk it? Negative 3 times positive 8 is negative 24. Over on the right-hand side, 3 times x is 3x. 3 times negative 4 is negative 12. And then that plus 6x is still there. And so we just distributed. Now what we need to do is we need to combine any like terms we have. And I'm seeing some over on the right-hand side there. We got that 3x and that plus 6x that can go together. All right, so everything on the left-hand side stays the same. Negative 3x minus 24 equal sign. 3x plus 6 more x's brings us up to 9x with that minus 12 still on there. Okay. After that, I got to move all my variables to one side. Right? So again, depending on how you moved your variables around, your problem might look a little different than mine, but check and see what the final answer is, right? You might need to skip ahead a little bit. If it comes out the same, then you probably were all right. So what I'm going to do is I'm going to add 3x to both sides to move them over to the right. All right, so they're gone from there. We're left with negative 24 on that side. Over on the right-hand side, 9 plus 3 gives us 12x, with that minus 12 still around. So all my variables are now on the right-hand side. That means that this 12, this minus 12, has got to go over to the left side. So negative 24 plus 12 brings us up to negative 12. Over on the other side, we have 12x and nothing else. Last but not least, there's a lot of 12s flying around, right? But what we got is we have negative 12, or we have 12 times x over on the right. We want to divide to get rid of that. So let's divide by 12 on both sides. Over on the left, we get negative 1. Over on the right, we just get x. And that's it. Right? So I'm hoping that that went pretty okay, right? I know that these problems are not easy. If you made a little mishap here or there, that's okay, right? As long as the general process is making sense, that's what I really want you to focus on. Okay. So what I'm going to tell you is that the next one is a word problem. We're not super duper focused on word problems. I am going to do it out. I'm going to talk through it. But if you're at a point where your brain is fried and you're like, oh my God, I can't take anymore, right? Feel free to skip it, right? We can talk about it in class if you want to. If you are interested in the word problem and it talks about dogs, right, then stick around. But if you are ditching out now, right, be sure to check on Google Classroom for any additional stuff. We'll do the practice when I see you in person. And please ask questions if you got them. All right. So if you are sticking around, thanks. All right. So for number 11, let's talk through a word problem together. A dog breeder raises two kinds of dogs. The average Labrador puppy weighs 13.4 ounces and gains 0.8 ounces per week. The average Golden Retriever puppy weighs 16.8 ounces and gains 0.4 ounces per week. What we're asked to do is to figure out after how many weeks will the puppies weigh the same amount. So what I like to do for word problems is we just read it through. I'm going to read it through again, but this time I'm going to grab important bits of information. So a dog breeder raises two kinds of dogs. The average Labrador puppy weighs 13.4 ounces and gains 0.8 ounces per week. Right? The average Golden Retriever puppy weighs 16.8 ounces and gains 0.4 ounces per week. What we want to figure out is after how many weeks will the puppies weigh the same amount. Okay. So you might notice that I use three different things there, right? Two different colors of highlighter and some underlining. So the stuff in the highlighter, right, I'm noticing that, this information is kind of in two categories, right? We have information about the lab puppies. We have information about the Golden Retriever puppies, right? The underlining is really what we're asked to find, right? That's what we, need to know, right? We need to know where we're trying to get to. So it's asking us after how many weeks will the puppies weigh the same amount, right? So if I don't know how many weeks, right, I need a way to talk about the number of weeks, right, without actually knowing it yet, which is really tricky. So the way that we do that is we use a variable. So I'm going to set myself up with a variable. Let's just call it W. So W is the number of weeks. I don't know what that number is yet for what the problem wants, right? But I can use W to kind of work with it without actually knowing it first, right? And when we're talking about them weighing the same amount, that means that I'm going to want an equal sign, right? I want these two sides to be equal to each other. All right, so now what I'm going to do, or what I might suggest, this helps me on some problems, right? It might help you out as well, is I'm going to split it up into two categories, right? We've got the lab side, and then we've got the golden retriever side. We want to figure out when they weigh the same amount, right? So that's where I'm going to put a little equal sign there. Okay. So over on the lab side is where all the information that's highlighted in yellow is going to go. And actually, make this real nice and colorful and color-coded and everything. There we go. So on the lab side, the puppy weighs 13.4 ounces, right? So a good starting point, 13.4. And then it's gaining weight, right? So on top of that 13.4, we're going to be adding on another 0.8 ounces per week. All right, so the way that I have it written right now, it's 13.4, and then it's plus 0.8. That only really accounts for 1 week of growth, right? If it grew another week, I'd then have to say, oh yeah, plus another 0.8. And then the next week I'd have to say, oh yeah, and plus another 0.8. And the week after that. And the week after that, right? And then I'm going to have this whole big drawn out thing with a bunch of plus 0.8s. I don't really want to do that, right? Because it's going to take up a lot of space. It's going to require a lot of writing. So the way that we can talk about, all these different situations at the same time is we can use our variable, right? So the key word here in the word problem is the word per. That's telling me that I have a rate at which it's changing, right? So it's gaining 0.8 ounces per week, right? So each and every week we're going to add on 0.8. So our mathy way of kind of shortcutting that is that if we use our variable and we just multiply that rate by the variable, right, per week, 8.8 times W, then that'll account for all the different numbers of weeks. If it's been 1 week, W is 1, and it's just 0.8, right? If it's 2, we'd add on 0.8 basically twice, right? Twice 0.8. Over on the other side, it's going to be kind of the same deal. The golden retriever weighs 16.8 ounces, and it's gaining 0.4 ounces each and every week. All right, so that's where our variable is going to go, right? This stuff in the green also has the word per that kind of clues us in there. So after this, it just turns into one of the problems we were working on earlier, right? At this point, we could honestly just kind of ignore the fact that it's a word problem and just focus on the numbers. So what we're going to do from here is we're going to, apply the same steps. I don't have any distribution to do because there's no parentheses. I don't have any like terms on the same side that I can combine, right? So we can skip over that. What I do need to do, though, is I need to move all my variables over to one side. Oops, I was a little bit hasty on drawing that in there. So to move my variables all to one side, let's subtract 0.4 W from that side. Whoops. All right, when I do that, I need to do the same thing over on the other side as well. So we got 13.4. We had 0.8, and we're taking 0.4 away. So we're still going to have 0.4 with a W there. Over on the other side, we have 16.8, and those W's are gone. So all my variables are over on the left-hand side. That means that this 13.4 has got to go over to the right-hand side. All right, and again, the way we're doing that is we're subtracting because there's a positive 13.4, so to cancel, we need to subtract. So those are gone. They are canceled indeed. 0.4W is equal to, on the other side, 16.8, minus 13.4. Should hopefully give us 3.4. Nice. All right. So from here, right, it still doesn't look pretty, right? Decimals are kind of gross looking a little bit, but it's still the same kind of problem. We have 0.4 times W over on the left. So we're going to divide by 0.4 to get rid of it. All right, so when I do that, those 0.4s are gone. We're left with just W. Over on the right-hand side, we have 3.4 divided by 0.4. It's going to give us 8.5. Cool, so now we know what W is. The one last thing that our answer needs is that because we're talking about a word problem and because we know that W is the number of weeks, we should put a little label. Whoops, sorry about that. We should put a little label on our answer, right? It's 8.5 weeks that we're talking about. So that's telling me is that these two puppies, after 8.5 weeks of growing big and strong, they're going to weigh the same amount, right? That's what the problem was asking us to do. All right, so this is a bit of a long lesson. Thanks for bearing with me if you're still around. All right, so again, check on Google Classroom for any additional stuff I might be telling you to do. Ask questions when I see you in person, please, 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 especially if you're a little shaky on these. We're going to practice with these some more during class, and let me tell you, these are not a particularly easy thing to do, and that's okay. That's why we're going to practice with them. All right, so that's it for now, and I'll see you next time.